year 1831, Faraday found that when the magnetic flux linked with a coil made up of conducting material is changed, the electromotive force is produced in the coil. The electromotive force which is produced in this way is called the induced electromotive force. This phenomenon is called electromagnetic induction. Experiment. A sensitive galvanometer is connected to the coil. A bar magnet is shown to be stationary with respect to the coil. In this condition, the deflection in the galvanometer is zero. That is, no electric current flows through the coil. Now, if the bar magnet is moved towards the coil, with its north pole pointing towards the coil, the galvanometer shows a deflection, which indicates that the electric current flows through the coil. If the bar magnet is moved with a greater speed, the galvanometer shows more deflection, which shows that a larger electromotive force is produced. Again, when the magnet becomes stationary with respect to the coil, the deflection in the galvanometer becomes zero. If the bar magnet is kept steady and the coil is moved, then also the galvanometer shows deflection. Now, if the bar magnet is moved away from the coil, the galvanometer shows the deflection in the opposite direction. If the above observations are taken by keeping the south pole of the bar magnet instead of the north pole pointing towards the coil, it is found that the deflection in the galvanometer is opposite to the corresponding deflection with the north pole towards the coil. Use of bar magnet is not always necessary to change the magnetic flux linked with the coil. As shown, if two coils S and P are kept close to each other and the switch K is switched on, then the galvanometer in S shows deflection and the switch K is switched off. Galvanometer in S shows deflection in opposite direction. Moreover, by keeping the current flowing in the coil and giving relative motion to the two coils, also the galvanometer shows deflection. By changing the electric current in the coil P, deflection in the galvanometer in the coil S can be seen.